Good morning. Today's quote is by Aristotle. Pleasure in the job puts perfection in the work. Pleasure in the job puts perfection in the work. Today's word is nemesis, something that a person cannot conquer, achieve, etc. The performance test proved to be my nemesis. In Marathi म्हणू शकतो आपण योग्य आणि अटळ अशी शिक्षा किंवा पराभव. Now this is 7 sum exercise 7.2. Let me explain, but please write the solution after the lecture. A company produces two types of articles, A and B, which requires silver and gold. Each unit of A requires 3 grams of silver and 1 gram of gold, while each unit of B requires 2 grams of silver and 2 grams of gold. The company has 6 grams of silver and 4 grams of gold. Construct the inequations and find feasible solution graphically. Let the company produce, it should not be produces, let the company produce X units of article A and Y units of article B. Now, this is the most important part. The given data can be tabulated as for article A, for article B, total availability. Now availability for what? Gold and silver. So there will be two inequations, one for gold and other for silver. And what is the constraint? Constraint is the rather availability. So what will be the equations? X plus 2y less than or equal to 4. Why? Because for article A, 1 gram of gold, but number of articles is X. So X unit of gold. For article B, per unit 2 gram and number of units Y. So 2Y. This means X plus 2Y, but availability is the constraint. It is maximum 4. So X plus 2Y less than or equal to 4. And for silver, 3X plus 2Y less than or equal to 6. Now X and Y are number of items. So can they be negative? No. So X greater than or equal to 0. Y greater than or equal to 0. These are called as non-negativity restrictions. So first we draw lines whose equations are X plus 2Y equal to 4 and 3X plus 2Y equal to 6. See, in exam, it is good if you write this, if you could write this rather. But I don't think you will be because you have to complete this part in just 2 to 3 minutes. But this is must that you write equations are, and these equations are represented by lines. Okay. So this is the graph. Now you will notice that first quadrant is to be taken into consideration, and for both the lines, origin side is to be taken into consideration. The reason is simple. 0 plus 0, 0, 0 are the coordinates of origin. 0 less than 4, yes. 0 less than 6, yes. So origin side of both the lines. So we have to consider this quadrilateral. Now, why not this triangle? Because it lies above the line CD, that is non-origin side. Why not this? Above AB, as simple as that. Okay. So this is nothing but the graph of the solution set. So this is feasible region. Sum number 8. A furniture dealer deals in tables and chairs. He has rupees 1,50,000 to invest and a space to store at the most 60 pieces. A table costs him rupees 1,500 and a chair rupees 750. Construct the inequalities and find the feasible solution. Write down. Let X be the number of tables. Write down. Let X be the number of tables and Y be the number of chairs. Y be the number of chairs. Then X greater than or equal to 0, comma, y greater than or equal to 0. I hope you are getting this. These are called as non-negativity restrictions. X greater than or equal to 0, y greater than or equal to 0. Next line. The dealer has a space to store. The dealer has a space to store. The dealer has a space to store at the most 60 pieces. At the most 60 pieces. Therefore, x plus y less than or equal to 60. Now, second constraint, some students directly say that as far as investment is concerned, or the constraint on investment is, but it is better if you explain that. Right now, cost of, I will directly say, cost of X tables is rupees, cost of X tables is rupees 1500X, and that of Y chairs is rupees 750Y. Since the dealer has rupees 1,50,000 to invest, 1,50,000 to invest, we have, write down 1500X plus 750Y less than or equal to 1,50,000. Now do not simplify this. While considering an equation, we can. While drawing the graph, we can. But here you cannot simplify this. You have to write this as it is. Okay. Now after that, you have to say, hence, the system of inequations. The system of inequations is right, x plus y less than or equal to 60. Then 1500x plus 750y less than or equal to 1,50,000. X greater than or equal to 0, y greater than or equal to 0. Previously, we used to get this part directly. We used to ask to solve this. Now we have obtained this. So the next part is, we say, first we draw lines. First we draw lines with equations, or whose equations are x plus y equal to 60. So which 2 points? Don't waste time in drawing this table, etc. I mean, using pencil and scale. You can use pen only for this. You're not supposed to use pen on graph paper. That's it. When y equal to 0, x equal to 60. When x is 0, y equal to 60. Then 1500 x plus 750 y equal to 1,50,000. That is, you can divide by what? Simplify this. You can divide by 750. So 2x plus y equal to 200. Check this. When y equal to 0, x is 100. And when x is 0, y is 200. Now you may say we will use 1 centimeter equal to 10 units. But for that, see whether 20 centimeters are available. Otherwise, all these are divisible by 20, 60, 100, 200. So you can choose 1 centimeter equal to 20 units. So that on y-axis max 10 centimeters, on x-axis max 5 centimeters are required. But I think if you are using proper size graph paper, which is given in the board exam, you can opt for 1 centimeter equal to 10 units. Choice is yours. Now draw the graph. This is the graph. Actually, problem should have been modified. But anyway, for these constraints, this is the graph. We are interested in considering first quadrant only. Now for both the lines AB and CD, origin side, that is below the line. So below CD, below AB. So this is the graph. First draw this, then I'll tell you the modified question and I'll directly show the graph. First complete this. Let me read modified question. A furniture dealer deals in tables and chairs. He has rupees 15,000 to invest and a space to store at the most 60 pieces. A table costs him rupees 150 and a chair rupees 750. Construct the inequations and find the feasible solution. So these will be the inequations and this is the graph and this is the shaded region. For both the lines, origin side, that is below the line. So the shaded region is the feasible solution. Just draw the rough sketch. Now we are in a position to discuss linear programming problems. See, the word programming means planning and refers to the method of determining a plan of action for the optimum use of available resources to obtain the desired objective. And obviously that objective will be to earn profit. If it is profit function, then maximization. And if it is cost function, then it is minimization. So we call this as optimization. The limitations on the resources will be called as constraints. The famous non-negativity constraints are x greater than or equal to 0, y greater than or equal to 0. Usually x and y stand for number of objects. If these limitations when written mathematically are of degree 1, if these limitations when written mathematically are of degree 1, that is linear, the programming is called linear programming. Now we are going to study the problems involving linear constraints using feasible solution, and that is why we have already discussed the meaning of feasible solution. We have discussed the concept of convex set also. Now consider the following problem. A manufacturer produces bicycles and tricycles, each of which must be processed through two machines, A and B. Machine A, machine A has a maximum of 120 hours available and machine B has a maximum of 180 hours available. Manufacturing a tricycle requires 6 hours on machine A and 3 hours on machine B. Manufacturing a bicycle requires 4 hours on machine A and 10 hours on machine B. If profits are rupees 45 for a tricycle and rupees 65 for a bicycle, formulate LPP to have maximum profit. Let us see how the information given above can be used to formulate in a mathematical form. In the above problem, the manufacturer is to determine the number of bicycles and tricycles which should be produced to earn the maximum profit. Let the manufacturer produce X bicycles and Y tricycles. Then the total profit to the manufacturer will be what? 65X plus 45Y. This is linear. We denote it by Z. So Z equal to 65X plus 45Y rupees. Now this is a linear function which is to be maximized and we called as an objective function. So here the main objective is to earn maximum profit. Now the constraints to the company are tabulated. Now you will ask me, sir, is this necessary to prepare the table? Actually, it is not, but you should not write constraints directly. It is better that you explain the constraints. Basically, the constraints are on what? Constraints are on availability of two machines A and B. So one constraint is for machine A, that is availability of machine A, and the other is for availability of machine B. But if you could tabulate the data, then constraints can be written directly without explanation because this much is sufficient. This is self-explanatory. Since the number of bicycles and tricycles is non-negative, we have X greater than or equal to 0, Y greater than or equal to 0. These are non-negativity restrictions. From this, it is clear that region in the first quadrant, including points on positive X-axis and positive Y-axis, are to be considered. Now, one bicycle requires 4 hours of machine A. So, X bicycles will require 4X hours on machine B. Similarly, Y tricycles require 6Y hours on machine A. So, total requirement of machine A is 4X plus 6Y in hours. However, machine A is available only for 120 hours. So, we get the first constraint, 4X plus 6Y less than or equal to 120. Some students, they simplify and they say that it is 2X plus 3Y less than or equal to 60. You won't get marks for that because 120 has meaning. 120 means machine is available for 120 hours. Of course, while drawing the graph, we consider equation, corresponding equation, and at that time you can simplify. Similarly, for machine B, the constraint is 10X plus 3Y less than or equal to 180. Now, this is the most important part. Hence, the mathematical formulation of the given problem is maximize Z equal to 65X plus 45Y subject to the conditions, restrictions, constraints. 4X plus 6Y less than or equal to 120. 10X plus 3Y less than or equal to 180. X greater than or equal to 0. Y greater than or equal to 0. Expression 1 is objective function. Expression 2 and 3 are constraints. Expressions 4 and 5 are called non-negativity restrictions. All these expressions, that is objective function, constraints, and non-negativity restrictions, are linear functions of two variables in X and Y. That is, index of each of the variables X and Y is 1. Such problem is called linear programming problem. Now, there are certain terms related to LPP. LPP, if the restrictions when expressed mathematically are in the form of linear inequalities, the programming problem is called linear programming problem. The restrictions are called constraints. Objective function, the linear function Z equal to C1x1 plus C2X2 plus C3X3 up to Cn Xn, whose maximum or minimum, which is called as an optimum value, is to be found out. It is called an objective function. In the syllabus, only up to 2 variables. So no third variable will be involved. Now, areas in which linear programming can be used. Manufacturing problem. In this type of problem, we determine the number of units of different products which should be produced and sold by a firm when each product requires a fixed manpower, machine hours, labor hours per unit of product, warehouse space per unit of the output, etc. in order to make the maximum profit. Diet problem. In this type of problem, we determine the amount of different kinds of constituents which should be included in the diet in order to minimize the cost such that it contains a certain amount of each constituent. Then transportation problem. In this type of problem, we determine the transportation schedule in order to find the cheapest way of transporting the product from factories to different markets. Problems related to investment market. In this type of problem, we establish the investment portfolio from a variety of stocks or bonds to maximize the company's returns on investment. And next one is problems in advertising firms. In this type of problem, we maximize the effectiveness of advertising activity in the fields of TV, radio, newspaper by allocation of limited advertising budget. This is very interesting. Fifth one. You must be knowing the rates of advertisement on TV. For few seconds, they charge lakhs of rupees. Mathematical formulation of LPP. The formulation of LPP as a mathematical model involves the following steps, simple steps. Identify the aim or objective which is to be maximized or minimized, that is optimized, and you have to denote it by Z. Identify the variables and assign symbols X, Y or X1, X2, X3, etc. Usually we go for X and Y because at the most 2 variables will be there. Identify all the restrictions or constraints in the problem and express them as linear inequalities or equation in terms of variables. Express the hidden conditions generally involve non-negativity of variables. You won't be given that number of items is not negative. You should know that. Now, fortunately, we have to study LPP with at the most 2 variables, and we shall restrict to LPP involving non-negativity constraints only. Exercise 7.3. A manufacturing firm produces 2 types of gadgets, A and B, which are first processed in the foundry and then sent to machine shop for finishing. The number of man hours of labor required in each shop for production of A and B and the number of man hours available for the firm are as follows. Good. They are directly given in tabular form. Profit on the sale of A is rupees 30 and B is rupees 20 per unit. Formulate the LPP to have maximum profit. Let the number of gadgets A produced by the firm be X and number of gadgets B be Y. So after that, you can immediately say, therefore, X greater than or equal to 0, Y greater than or equal to 0, or you can write this at the end also. The profit on the sale of A is rupees 30 per unit, and on the sale of B is rupees 20 per unit. So what is the total profit? It is Z equal to 30x plus 20y. This is a linear function which is to be maximized. You have to write this. Hence, it is an objective function. The constraints are as per the following table. So constraints are again on the availability of time in hours. See, depending on the availability of time in exam, you can decide whether to explain these constraints or not, or you can directly say that the constraints on total available time in foundry section, in machine shop, etc. From the table, total man hours of labor required for X units of gadget A and Y units of gadget B in foundry is 10X plus 6Y in hours, and the total man hours of labor required in machine shop is 5X plus 4Y hours. Since the maximum time available in foundry and machine shops are 60 and 35 respectively, we have the constraints 10X plus 6Y less than or equal to 60, 5X plus 4Y less than or equal to 35. Since X and Y cannot be negative, we have X greater than or equal to 0, Y greater than or equal to 0. Now this is the most important part. Hence the given LPP can be formulated as maximize Z equal to 30X plus 20Y subject to constraints 10X plus 6Y less than or equal to 60, 5X plus 4Y less than or equal to 35, X greater than or equal to 0, Y greater than or equal to 0. Now second sum, in a cattle breeding farm, it is prescribed that the food ration for one animal must contain 14, 22 and 1 unit of nutrients A, B and C respectively. Two different kinds of fodder are available. Each unit of these two contains the following amounts of these three nutrients. See the table. The cost of fodder 1 is ₹3 per unit and that of fodder 2 is ₹2. Formulate the LPP to minimize the cost. Only formulation is to be done. We are not asked to solve this graphically. This will be asked for 2 to 3 marks in exam. Write down. Suppose X units of fodder 1. Write down. Suppose X units of fodder 1 and Y units of fodder 2 are prescribed the cost of fodder 1 is ₹3 per unit. Yes, you have to write this. The cost of fodder 1 is ₹3 per unit and that of fodder 2 is ₹2 per unit. Therefore, total cost in rupees is Z equal to 3x plus 2y. Z equal to 3x plus 2y, which is to be minimized. Hence, this linear function is an objective function. Using the table, fodder contains, see on the screen, 2x plus y, comma, 2x plus 3y, and x plus y units of nutrients of nutrients A, B, and C respectively. A, B, and C respectively. As the minimum requirements of these are ARE 14, 22 and 1 unit respectively, we have, now tell me what will be the equations. We have 2x plus y greater than or equal to 14. Why greater? Because minimum 14 means 14 or more than 14. Then second, 2x plus 3y greater than or equal to 22 and x plus y greater than or equal to 1. Right? See, this is the minimum which you are supposed to write. If possible, you have to prepare a table also, but at least you should write this much. Since number of units cannot be negative, next line write down. Since number of units cannot be negative, x greater than or equal to 0, comma, y greater than or equal to 0. Next line. Hence, the given LPP is see on the screen. Minimize z equal to 3x plus 2y subject to, write down, subject to 2x plus y greater than or equal to 14, 2x plus 3y greater than or equal to 22, x plus y greater than or equal to 1, x greater than or equal to 0, y greater than or equal to 0. That's it. Third sum, a company manufactures two types of chemicals A and B. Each chemical requires two types of raw material P and Q. The table below shows number of units of P and Q required to manufacture 1 unit of A and 1 unit of B and the total availability of P and Q. The company gets profits of rupees 350 and rupees 400 by selling 1 unit of A and 1 unit of B respectively. Basically, at this point, we get an idea that we have to take X units of chemical A and Y units of chemical B. As simple as that. Assume that the entire production of A and B can be sold. Okay. How many units of chemicals A and B should be manufactured so that the company gets maximum profit? Formulate the problem as linear programming problem to maximize profit. Actually, you're not supposed to write in short, like X units of chemical A, Y units of chemical B. Total profit is Z equal to rupees 350x plus 400y. This is a linear function to be maximized. Hence, it is an objective function. You have to describe this, why total profit is 350x plus 400y. Okay. I have written this in short. Now, Type the constraints in chat box. Now, considering the availability of raw materials P and Q, what are the constraints? 3x plus 2y less than or equal to 120. If possible, elaborate this. Sufficient to elaborate first one, second can be written directly. 2x plus 5y less than or equal to 160. As x and y cannot be negative, x greater than or equal to 0, y greater than or equal to 0. So what is LPP? Maximize z equal to 350x plus 400y subject to 3x plus 2y less than or equal to 120. 2x plus 5y less than or equal to 160. X greater than or equal to 0. Y greater than or equal to 0. Fourth one, a printing company prints two types of magazines A and B. The company earns rupees 10 and rupees 15 on magazines A and B per copy. These are processed on 3 machines, 1, 2 and 3. Magazine A requires 2 hours on 1, 5 hours on 2 and 2 hours on machine 3. Magazine B requires 3 hours on 1, 2 on machine 2 and 6 hours on machine 3. Machines 1, 2, 3 are available for 36, 50 and 60 hours per week respectively. Formulate the LPP to determine weekly production of magazines A and B so that the total profit is maximum. Suppose X magazines of type A and Y magazines of type B are printed. So what is the total profit? Rupees 10x plus 15y. This is a linear function to be maximized. Hence it is an objective function. Now, ideally you should make the table. If not, explain one of the 3 constraints. See, constraints will be again on availability of 3 machines, 1, 2 and 3. Right? Just explain one, you can directly write remaining 2. Now the total time required for machine 1 is 2x plus 3y hours. As it is available only for 36 hours, 2x plus 3y less than or equal to 36. Similarly for machines B and C, 5x plus 2y less than or equal to 50. 2x plus 6y less than or equal to 60. Also x and y, that is number of prints, cannot be negative. So x greater than or equal to 0. Y greater than or equal to 0. Hence LPP is maximize z equal to 10x plus 15y subject to which constraints? 2x plus 3y less than or equal to 36. 5x plus 2y less than or equal to 50. 2x plus 6y less than or equal to 60. And finally, x greater than or equal to 0, y greater than or equal to 0. Write this. Then I'll show you the solutions for homework sums and then we'll stop. Now I think these are 2 sums. They were given for homework, exercise 7.2. This is the 5th one. This is the graph. And this is sum number 6. So that's it for today.